Lumiere from Google Research is a new space-time diffusion model for realistic video generation. So it's a new model for realistic video generation. So what are the things which this model is capable of? It is capable of text to video. For example, the text prompt over here is US flag waving on massive sunrise clouds. This is another example of a funny, cute pug dog feeling good listening to music with big headphones and swinging head. So given that text input, this is the video which has been generated. It can do image to video. So given an input image and a text prompt, it can generate a video. For example, over here, given this input image of a sad cat in a striped navy blue shirt, it generates this video. Okay, there are other wonderful examples of this over here. It can do stylized generation. So using a single reference image, Lumiere can generate videos in the target style by utilizing fine-tuned text-to-image model weights. Okay, so here are some of the examples of, this is an input image. Now here you have this an owl perched on a branch. So based on this style, right? These are some of the examples which have been generated over here. Okay. So this was for this image, and this is this thing. So here it is a lion with a majestic mane, and you have this 3D melting gold. Okay. So that's the thing, right? Here is a reference image of the style, and you want a flat cartoon, and this is how this is a bear twirling with delight. So these are some of the images which have been generated over here, right? So it can also do video stylization. So there is this source video, and then you have this prompt which says made of wooden blocks, and you can see this conversion over here, right? Made of flowers. The examples over here are very impressive. Look at this example, right? You have a car, and then you have this is like car made of blocks, car made of flowers, Lego bricks, right? Made of colorful toy bricks. Some of these videos are excellent, right? It can also animate the content of an image within a user's provided region, specific user provided region. So given this input image and a mask, it can generate an output video for you. It animates this particular mask region. This is also quite amazing. The examples shown over here, right? These videos are very amazing. Then it can do video inpainting, right? Given a source with a masked video, right? It does, generate video for that masked part over here. Right? This is another example. Here is another example. So it does a really good job of given video inpainting. Right? So yeah. So these are some of the tasks which this model can do. Now, what is the architecture between this model and how is it different from your current video diffusion models? Okay, so I looked into the paper, and here they've explained that if you look at the current models, okay, let me zoom in a little bit. If you look at the current models, the idea is that you generate certain keyframes. Okay, the base model tries to generate certain keyframes, and then you use a super resolution model to actually convert this low quality video into high quality video. Okay, so the most common approach consists of a base model that generates distant keyframes. Okay, for example T1, T6, some T50, right? And it uses a cascade of temporal super resolution models which subsequently fill in the frames. Okay, between the keyframes, it fills in the frames. Okay, then there is a spatial super resolution model which is applied on non-overlapping frames to obtain the high resolution final video. Okay, now this new approach, what it does is that it generates all the frames of a video. It doesn't just generate the keyframes. Okay, the base model in this frame processes all frames at once. Okay, and then what it does is that it does a super resolution, okay, spatial super resolution on overlapping frames, and then something called as multi diffusion to generate the your high resolution video. That is a key difference between existing approaches versus Lumiere. This they call it as space-time diffusion model. So the model architecture is present over here. So they call this as space-time diffusion model, and they are using this space-time unit over here. So they take a pre-trained text-to-image unit architecture, okay, and they convert this into this space-time unit where it down and upsamples the video in both space and time. So that is what they show over here. So there are convolution blocks over here which consists of pre-trained text to image layers followed by a factorized space time convolution, and there are attention based blocks at the coarsest unit level in which pre-trained text to image layers are followed by temporal attention. So this is a way of generating the frames as well as the movement across the frames. That is where this temporal part comes into picture. Okay, right. For further details over here, we need to look at this particular section. I won't be talking about that over here, but you can look at this paper for further details on this particular architecture. Okay, so this is what they call as space-time unit architecture. And if you were to look at how did they train this, okay, they are talking about the applications, but on what kind of data did they do a training, right? So they trained this particular model on a data set containing 30 million videos along with their text caption. These videos are 80 frames long at 16 fps. Okay, they are 5 seconds basically, and 5 seconds long videos, and the base model is trained at 128 into 128, and the super resolution outputs are from the spatial super resolution outputs are 1024 into 1024 frames. They evaluate this model on a collection of 113 text prompts describing diverse objects and scenes. Okay, so that is what they have used for training and the evaluation over here. This is at a very high level. To go to a lower level, we need to understand, what are these various components of this unit architecture and how it is done. Probably we need to refer to some previous papers to understand more about what is this particular ST unit architecture. Okay, right? So I'm not going into those details over here. So this is like a very high level view of what is the idea over here behind this particular paper and the Lumiere model. Other interesting things are they've compared it with these different models on performance. Basically, you also have other runway. Basically, they have their video generation models and other things. So yeah, so this is about Lumiere from Google, which is a new video generation AI model. So they had released something called Video Poet sometime back in December. I had already covered that. So this is Lumiere. So this is a different approach when compared to Video Poet. The thing is that none of these models are currently released for use or something. I hope maybe in the future, probably because of safety concerns and other things, I hope maybe in the future they release it as part of some API where you can give your prompts and really test it out. Currently it is just these demos by which we need to kind of get a feeling of how it works, right? Whether it works on your prompts, your data set and other things will be tested. We can only test it if they release this as some API or something. So currently they have just released a paper. I'll be putting the link of this website along with the paper in the description of the video. I hope this video is useful to you. If you like the video, please like, share, subscribe to the channel. See you in another video.